Alright, so in class we had talked about using the normal curve rule to find probabilities. But as we talked, and when we looked at some of the pictures last time, what we saw is that every number we worked with fell exactly a certain even number of standard deviations away, whether that be 1, 2, or 3 standard deviations away. However, there are going to be times we want to find probabilities that are based upon things that are not an even number of standard deviations away. So in this video, we're going to introduce you to finding probabilities, so we're going to figure out how to do that. So the first thing that we have here is talk about like a little 6 steps of kind of what I'm going to go through to find a probability. I have them listed out at first. That way when you're first doing these on your own, you have something to refer back to. But usually you'll get to the point where you do this without even thinking about it anymore. We're going to be using the Z table. So the first thing I'm going to do is actually pull that up because you're going to be using it, and that's where I'm going to be using it as well. It's going to be under your course documents folder, and it's going to be a tables and formula sheet folder, and then there's this normal table. So we're going to be using that for this video. Bring it up a little bit bigger here so we can see it. So we're going to have that for a reference here. So we're going to start with actually skipping this page temporarily and understand how this is going to work from going through an example. Sometimes that makes the most sense, is just to try an example and see how that really affects things. So we are going to work with our women's height. That can be approximated by a normal distribution. The mean is 65. So again, this is kind of giving my mu. And a standard deviation of 2.75. So that's going to be our sigma. Again, this is a reminder of our little shorthand notation here. So Y this time represents a woman's height. A little squiggly means distributed. Normal. And then the two numbers going to tell us the mean and the standard deviation. So we're going to use this. We're going to first find the probability that a randomly selected woman is 63 inches or shorter. So I go back here, I'm going to go through these steps. So the first thing I'm going to do is graph my bell-shaped curve and put the mean on it. And I'm also going to put my little increments of my standard deviation on here as well. Right, so our mean is 65. And I'm going to go my 3 standard deviations in either direction. So I'm going to use this 2.75. So we're going to subtract 2.75 as we're going to the left here. So we get 62.25 for that one. Subtract another 2.75. We get 59.5, and another 2.75. We get 56.75. I'm going to do the same thing by adding that 2.75. So we get 67.75, 70.5, and 73.25. So we have the first step done. Now it says we're going to graph the value or values of interest on the plot, basically relative to the mean. We're going to put the number where it belongs. So we're interested in 63. So 63 falls about right here on my picture. I'm going to go down here where I can label it a little bit better. So there's where 63 would fall. Next, we're going to figure out what we're interested in and shade appropriately. So it says we want 63 inches or shorter. So which way are shorter people? That means I'm going to shade everything smaller than our 63. So notice I can't use my normal curve rule on this one because I didn't fall an even number of standard deviations away from the mean. So I can't use that 68, 95, 99.7 idea because I fell in between this first standard deviation below the mean. So what are we going to do next? We're going to find our Z value next. Alright, so a little reminder of our Z formula. So our Z is Y minus mu over sigma. I have my mu, I have my sigma, my Y is that number I'm actually interested in. So for us, that's going to be 63 minus 65 over our standard deviation of 2.75. And when we do that math, we get a negative 0.73. And remember, it's negative because we fall below the mean. We're not quite one standard deviation below the mean. So that's kind of where having these little increments on here can help us see why that z-score is what it is. Next, we're going to go to the appendix, so basically the table appropriately. The appendix D refers to if you actually bought the textbook, or you can just use the table that I gave you out on Blackboard, and it's the same thing. So we're going to go and use our table appropriately. So now let's talk about this table a little bit. So at the top of this table, one of my favorite things about it is it has this little picture. And it tells me the table always shows the area to the left of a z-score, and it has this little picture here to remind me of that. When I look at my table, I have two different types of numbers that live in here. I have what's called my z, which is what we've been calculating up to this point already. And then we have these inside numbers that all have 4 decimal places, and those represent probabilities. So let me kind of give a quick little example in here. So I'm looking at my table, and let's say for an example, I want to think everything to the left of the value where my z is equal to negative 1.07. So I'm looking at my table, that z is my row in my column that I live into. So if I look at my z, everything up to the first decimal point will tell me which row to go to, and the second decimal point will tell me what column to go to. So I look at that on my table. I go to the negative 1.0 row, which is right here. And then I go over the 0.07 column and see where those line up, and I find this 0.1423. Now what that number is actually telling me is that this shaded area here is 0.1423. Or if you prefer to think percentages, there's 14.23% to the left of that number. Okay, how does that actually work with our example that we're talking about here? Well, so what we have here from looking at my picture is we want everything to the left of 63. But 63 is not a z-score, so I can't take that number to that table. I need to change this 63 to a z first, which I've actually already done. So now I'm going to take this negative 0.73, and I'm going to take that number to the table. And we're going to look that number up. So here's my negative 0.7 row in my 3 column, and I find this 0.2327. That's what I got from the table. Now where that picture is helpful for us, that number I just found, this 0.2327, is whatever is left of the z-score. So if I wanted to put that then on my picture, that is then telling me that this area here is 0.2327. And that's actually exactly what I wanted, right? I wanted to find this shaded area. So that actually is going to be my answer. My probability is 0.2327. Or sometimes it can help, it's going to seem a little silly at first, so I am going to actually have you interpret an answer once we're done. That way you can see, hopefully, that it makes sense. So then here I'd be able to say that the probability that a randomly selected woman is 63 inches or shorter is, I can either say 0.2327 or I can say 23.27%. Now looking at our picture, hopefully the ballpark of this number makes sense, right? So if I had everything to the left of 65, that would be cut my data right in half. So I can tell from my picture that my answer should have been less than 50%. You might not remember these exact percentages from like the normal curve to kind of know what that number is going to be between. But it's still nice just to have it on that picture for understanding that part of it. So there's basically 23.27% of women are 63 inches or shorter. Alright, that was probably one of the more that one that's straightforward. So let's try one that's a little bit more complicated. We want to find that probably a randomly selected woman is 70 inches or taller. So I'm going to start in my same way. I'm going to first draw my picture. I'm going to put my little markings on here. I'm still working with women's heights. These are all going to be exactly the same as the picture above because I didn't change any of my numbers. And that should be a 6. This time the number 70 shows up in the problem, which is about right there. And this time it says 70 inches or taller. So since it's taller, that's going to tell me to shade to the right. So again, we've done basically the first 3 steps, or to draw the picture. Our next step again is to find the z. We already again have a reminder of what our formula is up here. So if I find my z, this time my y is the 70. My mean is still 65. My standard deviation is still 2.75. So neither of those numbers have changed. This gives me the number positive 1.82, and I can see from my picture, right, that it's 1, not quite 2 standard deviations above the mean. That's why it's smaller than 2. Next thing we're going to do is take that number to the table. All right, so again, this part tells me the row to go to. That one tells me the column to go to. So let's pull up our table. So positive 1.82. So just the other side of the sheet gives me the positive z-scores. So here's the 1.8. And here's the 2 column. So there's our 0.2, the 1.82. So we get 0.9656. Now keep in mind that number I just found is what's shaded to the left. So if I go back here, if I actually wanted to put my number on the picture just like I did in the one above, so technically that 0.9656 is this side. Notice that's not what I actually want, right? I want this little pink area. Now for some of you, I'm sure it's obvious what we're going to do, but we're going to go ahead and go back to the previous page and talk about some useful relationships of z-scores. So we're going to do the first rule, and this rule is our shaded right rule. So whenever you're shaded right, this is what we're going to be doing. And I do the idea here with a picture because I think it makes a lot of sense. So whenever I want something that is shaded right, and I want to use the table that I have at shaded left, so I need to work with that. So what I'm going to do is I'm going to start by taking everything, which is basically 1 or 100%. So I'm going to take everything and subtract off what I don't want. And so if I take everything minus what's on the left, I'm going to be left what's on the right. So my similar idea here is if I'm eating dinner with someone, they say, well, you take what you want, I'll eat what's ever left. So we start with everything, I take what I want, they're going to eat what's ever left over. So So we're going to start by taking 1 minus whatever we have here. So how that applies to our example. So our 0.9656 we just found was to the left. That's not what I want. So my actual probability is going to be 1 minus that 0.9656, which gives me 0.0344. So I can put that on my picture here now too. And right, so I mean now if I add those two numbers together, I have 100%. I have everything. Which piece I actually want is my shaded pink piece here. So that's going to be my probability. So if there's a little thing to remember, right, so if I would have got 96.56 as my answer and maybe not realize that I should have done the 1 minus what was going on here, this is where the picture can be helpful too, right? I know if I took everything to the right of 65, that would be 50%. So I can tell I have less than half of my picture shaded. So if I got a number that was bigger than a half, I would have known I've done something wrong. Also here we know a little bit about the context of the problem, and if you were to tell me that about 96% of women were taller than 70 inches, that's not going to seem right to me. So there's like little things we can do to see if our answer makes sense once we're done. Last, I'm going to interpret this. So we can say the probability that a randomly selected woman is 70 inches or taller is our 0.0344 or 3.44%. And hopefully the idea of the 1 minus rule, the shaded right rule, makes sense. So for example, if we were in class and the first thing you asked me was, what percent of students pass this class? And if I said, well, about 10% of students fail the class. What percent of students pass? Right? It's the other 90%. So I give you sort of the opposite of what you wanted. You can still find what you actually want from that value. Alright, so far we have an example of one that's been shaded left, one that's been shaded right. Let's look at the other example. We want to find the probability a randomly selected woman is between 63 and 69 inches tall. So we're going to start this again in the same way. So we're going to start by drawing the picture. I'm going to put my little markings on there, just as I did before. And this time we have two numbers that show up in the problem. We have 63, which is roughly about here, and 69, which is roughly about here. And it says we want between those two numbers. And so if I compare this to our previous two examples, it's not just shaded left and it's not just shaded right. More specifically, we even have two numbers that show up. But we're going to start it the same way. So let's find our z-scores. This time we have two of them. So I'm going to first find my z, where my y is the 69. Still subtracting off my mean of 65. Still dividing by my standard deviation of 2.75. And we get a positive 1.45, right? We're in between the first and second standard deviation above the mean, hence it's positive in between 1 and 2. So I've got the same idea here for my 63. I'm not quite one standard deviation below the mean, so I know for that one I'm going to get something that's negative, but not quite a negative 1. It's not a full standard deviation below. And we get negative 0.73. Right. Now my next part of my process is to go to the table. So I just have two different numbers to go to the table with. So we're just going to look them both up. So first I'm going to look up the positive 1.45. Again, keep in mind, first two numbers are my row, second number is my column. So we're going to get a positive 1.45. So for that number, we're going to get 0.9265. And then also goes with the table with our negative 0.73. So here's our negative 0.7 and the 3. So we get 0.2327. Now, first of all, we have two different numbers from the table. We might not be sure what to do with them. But remember, this tells me everything to the left of numbers. This isn't all shaded left. It's not all shaded right. So what I've done up to this point doesn't apply. I need my second relationship here. And this works whenever you're working between two numbers. So if I have my picture, and I'm trying to find between 2 points, doesn't matter where these points fall. They can both be smaller than the mean, both be bigger than the mean, one be on either side of it. Doesn't matter as long as you're shaded between. And I want to use the table that I already have to find this. So the first thing I'm going to do is I'm going to start with looking at where my B is. And if I go to the table and look that up, I get everything to the left of it. Now if I compare this picture to this one, what I can tell is this one has more shaded than this one. So what's going to tell me is I need to subtract off something, so I have too much. What can I subtract off of this picture to get this picture back? Well, I want to get rid of this little piece. Okay, I don't want this everything to the left of A. If I subtract off everything to the left of A, I'm going to be left with what's in between those two numbers. So that means how I'm going to use this rule for my actual problem here is I already have both of those probabilities. This is the first picture, and this is the second picture. So what I just need to do then is to subtract those two numbers. So I'm going to take the 0.9265 minus the 0.2327, and that's going to get me 0.6938. Now, I'm not going to require you to put the numbers on the picture here for this one, especially because it's a little bit harder. And so what I found here is that this is 0.6938. This 0.2327 is technically this piece. And then you can find this one just by knowing that things had to add up to 100%. Again, I'm not going to force you to complete the picture, but this is going to be 0.0735 if I wanted to find it. Right, all I really care about is that you know to go to the table with both numbers, you subtract those two numbers to get our answer here, and that will give you the between part. Of course, last I'm going to interpret it. So then we can say that our probability that a randomly selected woman is between 63 and 69 inches tall, is our 0.6938. Or, again, if you want to do the percentage, 69.38%. Now, I don't care if you do percentages or decimals, that doesn't matter to me. Right, so from using this table and learning these two new rules, you can find any probability. So in class, we're going to practice that a little bit more.